Let's wait for your classmates. I'm going to give them 3 minutes to go. Mic, mic test. Meron na ba? Mic test. Celia, naririnig mo ba ako?
Opo, sir. Narinig po.
Oo, malinaw ba?
Yes po.
Okay, thank you very much. Wala pa, ayun. Kararating na din ni Sok dyan. Okay, let's get started. Okay. Last meeting we talked about the one of the four major worldviews. We have the Aristotelian. Apat sila, no? Ayan. So while this thing is going on in our country, no, nag, uh, there are different influence from different regions. In Europe, what was happening is that they were evolving science. No? We have four major stages: the Aristotelian medieval worldview, Cartesian worldview, Newtonian, and then the contemporary science or the science right now. No? Starting from Cartesian worldview, we have what we know as what we have the science as we know it. Starting from Cartesian, this is more philosophical. Again, a short recap. Okay, a short recap. The Aristotelians believe that there are only four elements because these are the precursor scientists, no, the kumbaga proto scientists. Before we have scientists, we have natural philosophers. One of the major one is Aristotle, fire, water, earth, air, and then two of them are heavy, and then their medicine is also based upon the four elements, no? A combination of four elements. According to them, our body is made up of the yellow bile, blood, phlegm, and then the black bile. Depending on the balance of the three, you can have different personality. You have choleric, phlegmatic, sanguine, and melancholic. So you may observe this in your classmates, no? Different classmates, different personalities. And as and it is also used, the four elements is also used in astrology. We have here a set of water elements, we have a set of fire elements, we have a set of earth, and then you have a set of air elements. And these zodiacs, this symbol what uh, may influence your behavior for that day or month. And then their cosmology is also based upon the four elements. You have earth, water, air, and fire. So this is the Aristotelian worldview. Okay, it is natural philosophy based on Aristotle. So it's intuitive. For the people in the past, it is easy to understand. No, you can believe it because it makes sense to them. It perfectly makes sense. And then you can observe it. Uh, you can observe that heavy objects like earth, rocks, they fall down, and then light objects like air, in case of smoke, no, it goes up. And it is qualitative. It is descriptive. There's no mathematics involved. They are just describing their observations. Okay, now we have the second worldview. The second worldview overtook the first one. So the second worldview, the Cartesian worldview, replaced the Aristotelian worldview. It replaced the four elements. How was it able to replace the four elements? How come? How did the Aristotelian allow it? Okay, according to Cartesian, uh, for the Aristotelians to convince them that you have a correct worldview, you must make you must formulate or you must present your theory, you must present your claim as intuitive as possible. So if you're going to meet a council of Aristotelians, no, you go to their council, you face them, and then tell them about your uh, claim about the world, but make sure that it is intuitive, no, easy to understand, and it is also observable. Okay. Okay, so the first step in the Cartesian worldview, or the first step in convincing the council that we have a better worldview, is to claim that, okay, if our worldview is the best, then if we doubt everything, we should we should arrive to the same worldview. So that was the idea, no? Because it's possible that we could be biased. There's theory ladenness. We could be biased, and this bias uh, forces us to select certain worldview. No, but for Cartesian, it may be, it may not be a good thing. No, we must doubt everything. That's why there are jokes in philosophy, no, about you not existing. No. Let's debate first if you exist or not, like that. It was one of the major contributor of that is Rene Descartes, the one who proposed to doubt everything. Okay, by that was the first step. That was the first step in transforming this system, this Aristotelian system, which is based on intuition, observation. Hindi ko pa change. I'm going to change this quick. Because I'll be giving this one to your classmates. No? It's not quantitative, it should be qualitative. It's intuition, observation, and qualitative. He transformed it into a different system, no, through doubting. He transformed the old natural philosophy into natural science. Natural science involved making hypotheses, experimentations, and mathematical formulas, mathematical descriptions. So this is natural philosophy, and then here we have natural science. Now, how did it happen? What was the transformation? What was the argument? How did he present his worldview to the Aristotelians? Okay, so To convince the council, you must follow these rules. No? It must be intuitive, it must be based on observation, not experiments, and it must be qualitative, no, not quantitative. Let's do that again. So, okay, he said to the Aristotelians, if your worldview is so intuitive, then if we doubt everything, then we should get the same conclusion. No? We should get the same conclusion about the four elements, no, about the four personalities, four major personalities. We should get the same conclusion about Aristotelian gravitation, and so on and so forth. Okay, so they did that. Okay, so this was what happened. This was the process. Let's say you doubt everything. You doubt that you are facing, you doubt that you are listening to your teacher. I could be an AI. I could be an AI talking to you. You doubt that you are holding a cell phone or laptop. No. You doubt that your hand is real. You doubt that there's a hand. You doubt that you have a body. Uh, You doubt that you have an eye, a physical eye. You can do it. You doubt that you are sitting to a chair. But there's one thing that you cannot doubt, right? You cannot doubt that you are thinking. So that was the first keystone in Cartesian worldview. You can doubt everything. No? You can doubt your anyone. You can doubt anyone. You can doubt everything. But there's one thing you cannot doubt, and that is thinking. You are thinking. Okay. So if you are thinking, then we can say that our mind really exists. So it's the only thing that we can be sure of. The only thing that we can be sure. We can be in a matrix. No, we can be plugged in a matrix, but we cannot deny the fact that our mind still exists in that situation. No? Okay, what can we conclude if our mind exists? Okay, if our mind exists, then we conclude that we can think. Okay, let's get this one. Let's get this conclusion here. Place it on this side. Okay, if we can think, then we can think of a perfect being in our head, right? We can think of a perfect being. So right now, I can think of a being that is purely benevolent, so purely good. No, he won't allow deception. He won't allow suffering. He will allow suffering for some reason. No, uh, uh, he want the best for everyone. I can think that in my head. Let's call it a perfect being. Uh, but that being is even more perfect if it exists outside our mind. Anyway, you can look at this argument. So you can say it may be faulty, it may be not. But that was his argument. No, we can think of a perfect being, but there is an even more perfect being, and that is the real equivalent of what we can think of. Kumbaga, the greatest possible perfect being ever. No, the greatest, because uh, it is not only existing in our mind. No, it is existing outside our mind. So, if there is a perfect being that exists outside our mind, let's call it God. That perfect being, that perfect benevolent being, let's call it God. So you prove the existence of two things. You prove the existence of your mind and the existence of the greatest possible being outside your mind. Okay, if there is a greatest possible being outside your mind, what can you conclude? Uh, Copy this one, no, on this side. Now, what can you conclude? Okay, you can conclude that since this being is benevolent, this being is good, he will not allow deceptions. Now, what are examples of deceptions? The A good example of deception is the matrix scenario. Now, in case of, let's say, right now, our mind is saying that there is a monitor in front of us. So, merong monitor sa harap mo. There's also a table in front of you. If these things does not exist, that means that you are deceived. No? But the perfect being will not allow that to happen. In that case, the thing that you are seeing, the monitor and your table, is an actual thing, an actual reality. So he now proves three things. Oh, Number one, you can prove that you can think. Number two, the perfect being exists. Number three, perfectly good being, a benevolent being exists. And number three, an objective reality exists. No, there is actually a table and chair, and we are not plugged into a matrix. Okay, if reality exists, what can we make of that? What can we conclude about that? Okay, if reality exists, according to Descartes, okay, then there is a part of reality that not is mind. Well, there is a separating. No, there, these two are different. No? There is a mind and there is a reality, no, matter. Kumbaga. Oo. So if an objective reality like the table, the monitor exists, then they are not the same thing as our mind. No? So now that we have proven that reality is different from the mind, then we can say that mind and matter exist. This position in philosophy is called duality. No, it's like yin yang. There is matter, and then there is mind. I think you are familiar with this one, no? Sa unification thought, unification principle. Uh, this view is held by the Cartesian. This is very a little. This is a little different from Aristotelian worldview because according to Cartesian, there's only two basic types of uh, objects in our universe. Two types of material in our universe. One is called the mind. I don't think material is a good term. There are two basic types of substances. No? The mind substance and the matter substance. This is very important to note. No? There are only two types, mind and matter. So mind substance or beings made up of mind, examples according to Cartesian are the perfect being and angels. So they are purely made up of mind. And then objects like the cup or your TV screen or the table you're using, they are matter only. But human beings, according to Cartesian, are combination of mind and matter. There is part mind and there is part matter. And this is also a very important note to take. There is only one example of a being in the entire universe that is composed of mind and matter, and that is human beings. The rest, including the animals, are just arrangement of matter. Okay. So this was his conclusion. So there are two substances that exist. There are only two substances, that's mind and matter. Not four elements, like not like that. No. He separated substance in a different way. No. Mind and matter. Okay. So if there is only two elements, mind and matter, then the whole universe, the whole universe must be filled up of matter. The whole universe is made up of matter. So the empty space, the air, the around you, kumbaga, the space around you, you can move your hand to feel the air. You can move your hand. You can see. You can actually feel it, no? You can try to move your like that. Wiggle your hand. There is an air. Because according to Cartesian, uh, that everything in the universe is composed of matter, no? Including the outer space that is composed of matter. No? Because of this worldview, that the universe is filled of matter, the Cartesian worldview is actually a clockwork. So it's a clockwork. If a gear moves or if a particle moves, it will affect the other particles, and so on and so forth. No, it will create a cascade of events. It will create a chain of events. Okay, so if you are seeing anything, if you are seeing a, let's say, or anything that moves, let's say your electric fan. Look at the electric fan. The electric fan is, according to um, Rene Descartes, it's just a clockwork. No? It's just a machine, no, of interconnected parts, no, of uh, different parts, and you can control how the machine behaves by manipulating how the parts interact. Uh, since human beings are made up of matter, the same thing can be said about the human beings. This is a step, kumbaga, a step more difficult, no, compared to the Aristotelian worldview. But he already proved this one, no, using his uh, doubting method, the Cartesian doubt. Okay, so the entire universe is made up of matter according to Cartesian. René Descartes. So there is no such thing as empty space. So if you think of motion, no, here I have an illustration of a billiard ball. No, if you push it with something, it will move. The movement of that billiard ball is not caused by the nature of the four elements. No, it was caused by a chain reaction. No, there you push the, what do you call that? No, the stick, the pole. I think it's called a pole. No, you push the billiard ball, then the billiard ball will start to move, and there is no movement without contact. No, there must be a contact first. Okay, so very different, no? Why is the why is the hot air going upwards? Because of a series of contacts or interaction of atoms. No, they are interacting such that some part of atom goes up, or some atoms goes up. Why why is the sailboat moving? Because of the air hitting the sail of the sailboat. So this is a Cartesian worldview. What else? If we believe that the entire universe is made up of interacting particles, then the diseases, uh, for example, there is a problem with your eye, uh, then if you are a Cartesian, you will believe that that problem is caused by a, kumbaga, an error, no, in the eye's mechanism. So, there's an error somewhere here. No, you can have your eye operated by something, by an expert, no, to fix that, whatever. If that is a cataract, no, the reason why you cannot see is because the cataract is blocking the particles that is helping you see. Now this is very different. This kind of medicine is very different from the Aristotelian, because the Aristotelian, if you have eye cataract, they believe that something is wrong with your balance of fluid. Maybe they're going to prescribe you some sort of liquid to drink, some sort of, or or some liquid to reduce, no, to avoid eating. But for Cartesian, everything is like machines, no. So if there is problem with your feet, the reason for that is a part of your feet uh, is not working. So the machine, a part of the machine is not working. So this is a very mechanistic view about the universe. Okay, for cosmology, how would we explain gravity? According to Rene Descartes, there is no such thing as empty space. Everything is filled up with matter, like this one. You know. So here you have suns. They already discovered the different suns. No? Unlike what's that? Unlike Aristotle, he believed that there's only our sun, no? And then the stars. But in Descartes' time, they already figured out that there could be different stars with different systems on it. Okay, so according to Aristotle, how does gravity work? Using interaction of particles. You probably remember that when you let's say it's a morning and then you get a cup, and on that cup you pour hot water, and then you fill it with uh, coffee, milk, and sugar. No, if you try to stir the cup, so, okay, let's illustrate that one. This may take a while. Okay, so how would you explain gravity using Cartesian worldview? All right, let's draw the cup. So here you have the cup. Okay. Let's say you filled it with hot water. Let's color it yellow. Hot water, that is yellow. And then you drop some milk particles, coffee particles, energen particles, whatever. You drop here the particles from its container. Oh. In some cases, the particles will float. Right? They'll float here. You can spread them. You can have them spread on the entire cup. And then, this is the cup. Okay. If you try to stir it, if you try to stir it, well, if you stir it with a spoon, if you stir it with a spoon, it will create a spiral. What is that? Spiral formation. No? We have a vortex spiral formation. And what do you observe if you create a spiral vortex? You observe that the particles will gather towards the center, somewhere here. They will tend to coalesce somewhere. They tend to gather here on the center of your cup. Okay, according to Rene Descartes, the same thing is happening with our planets. No, say you have Sun here, then you have Earth here. The Earth is like the coffee particles. No, the Earth is being dragged by very tiny particles, very tiny interacting atoms. No, matter, very tiny particles that is constantly revolving around the sun. So it's being dragged. Maybe some are more concentrated than others. No? So that was his idea. Same with the other planets. They are being dragged by the vortex. Okay, so that is a very interesting worldview. Because again, his worldview is very mechanistic. No, he claimed that everything must be made up of matter. Okay, so he was the first one to propose. Uh, he was the first one to convince the Aristotelians that if we're to discover the world, we should start with hypothesis. Like, what's the reason for that? Why did he propose that we're going to start a hypothesis? Let's start a new page. No, explain why do we have to start with a hypothesis. All right. In this case, I'm going to ask the class. No, the class. I'm going to ask the class to give any observation at all. Any observation. When you wake up this morning, give me an observation. Anyone? Kahit anong observation. Class. Anyone would like to give an observation? Let's say, I observed that it is cold this morning. Like that. So that's an observation. I observed that the chicken are being uh, what's that? The chicken are being okay. You can say you can observe that the chicken are being fearful. No. What else? Can you give me an observation? Anyone? Any observation at all? Have you noticed any changes in your place? In natural phenomena? Melanie, can you give us an observation? Anything? Anything unusual today? How about you, Warren? Can you give us an observation?
Hello, sir.
Anything unusual today? Temperature, movement, light, anything?
Temperature, sir.
What about it?
It's rain. Rainy day.
It's rainy day. Okay, let's have that one. Thank you very much, Warren. Let's have that one.
You're welcome, sir.
Uh, why is it? So let's have a phenomenon. No? Okay, let's have this phenomena. A phenomenon. The phenomenon of raining. Uh, this is uh, you observe this one in nature. You see it that there is falling water. All right. I'm going to give you. I'm going to give you everyone in the class that will participate 1 point now. If you have a good uh, theory. I'll try to be creative without using science, without using your knowledge about evaporation, condensation, no, and gravity, falling water. Try to invent. Imagine you are a person in the Greek era. No? Imagine uh, you are with Aristotle. No, try to invent an explanation for this phenomenon. Anyone who would like to try? Why is it raining? Try to answer that creatively. Anything, anything. Or invent an explanation. Anyone? Why is it raining? Well, I can say that there is a planet. There is a water planet. There is a water planet. No, and that water planet is affecting the clouds in the sky. Okay, what else?
Sir,
Yes, go
water
ahead.
evaporation, sir. Water evaporation.
Uh,
Same lang ba yun, sir?
try try not to use any scientific knowledge that you have right now. No, try to explain this. Make up explanations. Why is it that it is raining today? I can give you another one. Because there is a creature here. And
Sir, sabi daw ng iba, God is crying daw.
oh, it's
Di
possible,
ba?
no? Yes, yes, yes. Let's say there is a being, no, or God is crying.
Masuk ko naman.
Okay, one explanation that there is a being, anything, angels, fairies, whatever, that's crying. Okay, what else?
I think ano po sir,
Invent.
moisture.
Don't use your don't use your knowledge in science. Try to invent anything. Mag-invento ka to explain why there is
Sir, ano,
rain.
sir, ano, sir, LPA, sir, or low pressure area, or maybe, if not, sir, typhoon like that.
Um,
Science nga eh.
don't
Science yan,
again,
science.
don't use anything you know about science. Imagine you are in Aristotle's time. No, and somebody asks, let's say some kid asks you, ate or kuya, why is it that some water drop from the sky? Why is it that it is raining like that? No? Why? No, I remember an old man, no, in our province, dun sa Visayas, no. Talagang naalala ko siya. Sabi niya sa amin, mga tatlo kami noon na nandun sa kanya, nakakaharap sa kanya. May nagtanong sa kanya, bakit may kulog? Tapos sabi niya, hindi daw. Sinabi niya sa amin na, ano daw, may kumukulong tubig sa langit. Oh. Ganon yung explanation na. Bata pa kami noon. Hindi namin alam ano ba talaga yung explanation. Okay lang sa amin. May kumukulong walang tubig sa langit. Kasi yun nga yung sound ng thunder. Oo. It's like parang kumukulong tubig. Ganon. Okay, create an explanation. Or maybe the aliens, meron mga aliens dito, no. Maybe the aliens are playing with us, no. May mga aliens dito. Or there are beings there. Or they're playing with us, no. They are doing something that causes rain. So you can invent a lot of explanation. No? You can have another phenomenon. Bakit yung barkada mo ganito? No? Diba, meron kang barkada. Or sabi na lang partner na lang ng partner. O bakit ka na late? Ano ba? Bakit ka na late? You can invent a lot of explanation for that. May na traffic. Maybe hindi nakagising ng maaga, tulog. Pwede din, baka inutusan.
Hinatid yung bebe niya sir.
O hinatid yung bebe. Naghatid. Hatid. And so on. So you can list a lot, no? A lot of possible explanations. Now, the reason why Descartes proposed to balik muna tayo dito, no? So maraming explanation. All of them, lahat ng mga to. So if you are an Aristotelian during that time, Aristotle. If you are an Aristotelian, okay, you may find the traffic to be intuitive. And it is observable, it's possible. Intuitive siya.
Abigay lang yung mga minum ka ng vitamins market.
Sino ba yan? Pwede pakimute mo ang item mo. Okay? Tulog. Pwede nakatulog. This is also intuitive. About inutusan. Yes, it is possible. No? Madaling maintindihan ng explanation na to. Also intuitive. About naghatid. Also intuitive. Okay,
Tinamad pa sir, tinamad.
Tinamad. Also intuitive. So lahat sila intuitive. If you're going to follow Aristotelian method, sandali hala. It is intuitive at the same time it can be observed. Na-observe mo yung mga ganitong situation. It is also descriptive. Wala namang math dyan, no? Descriptive. Lahat sila pasok sa kay Aristotelian. Yung tanong dyan, saan dyan yung totoo? Parang kang mag-investigate. You're like investigating which of the explanation is the real one. So you can see that it cannot be all of them, no? All of possible explanation. It's not that all of them are the correct explanation. There may be few, no? So these are not enough filter. Dapat i-filter mo pa siya. You have to create a bit better filter. According to René Descartes, a better one is using a hypothesis. But there is a catch on this. If you are going to create a scientific hypothesis, then it must have a testable prediction. Testable prediction. Okay. If you cannot create a predictable, testable prediction, then your explanation will not be considered scientific by René Descartes. It will be considered more philosophical, no? Non-scientific by René Descartes. So, for example, traffic. Let's say you are late because of traffic. Now you must give a hypothesis. Why is he late? Let's say your hypothesis is he is late in traffic. Now if he is late in traffic, then you are going to ask for evidence, no, to show that he is indeed late in traffic. Let's say how would we test that he is indeed late in traffic? What would show that he is indeed late in traffic? So, no possible. You can ask him anything, no, about the route, yung dinaanan niya. Let's say may traffic ako doon. Okay, you can ask anything like let's say dumaan siya in that place. Okay, ano nakita mo dito? What have you seen here? What stores are here? Yung mga dinadaanan mo. What promos are they displaying today? So you should be able to see the posters here, no? If you can give a correct evidence, let's say I was late in traffic, no, I was late in traffic, and when I look on the sidewalk, I saw that, let's say I saw that Jollibee has a let's say 10% discount promo, no. If this is confirmed, if you're going to observe it, you're going to test it, that the Jollibee really show 10% discount, then there's a good chance that this is the correct explanation, that this explanation is correct. So hypothesis is a even stronger filter, no. Intuition is not very, it makes sense, the word it makes sense is not a very good filter. There are a lot of things that make sense, a list of things that make sense, but some of them may be wrong. That's why René Descartes proposed that we use a hypothesis as a better filter, a predictable hypothesis. What else? We must experiment. When we experiment, we must test for accuracy and precision. Kumbaga, sakto talaga, no? If you're going to predict that this will happen, since the universe is mechanistic, according to him, no, mechanical, it should happen. Let's say if you're going to throw something, throw an object, and then if you're going to, for example, drop an object, and then you have a prediction that it is going to cause this much damage, then that claim must be tested if it is accurate and precise, no? When we say accurate, it is the result is near to the prediction, and then we say precise, you can do it consistently, no? You can repeat the same outcomes. Okay, so, and then since the universe is mechanistic, you can describe a lot of natural phenomenon using mathematics. Baliktad na qualitative. Bakit qualitative? Ano that this should be quantitative or maths, no? You can, if the universe is a giant machine with moving parts, like, then you can describe the movements using numbers, no, not only purely description. You can even do better than that. Use numbers. Okay, now let's move to our third worldview. So René Descartes left us with a I think I'm really René Descartes left us with a universe that is composed of only two substances, no? Mind and matter. And then he improved the Aristotelian method, no? by adding hypothesis in your claims, by adding experimentations, and by using quantitative data, using numbers. So we are left with, this was the early version of early science, no, from René Descartes. Okay, next to that is the Newtonian worldview. So now what's the difference between Aristotelian and Newtonian? Let's talk about Newtonian worldview. Okay, chess analogies. So science is like if you do science, it's like you are watching a chess game. You are watching a chess game, and by watching the chess game, you can try to figure out the laws of the chess game. You can try to figure out how the knight moves, how a knight moves. You can figure out how a bishop moves. You can figure out how a king moves simply by observing the chess game. No? And if your observation is very consistent, you observe that the knight moves in L pattern, then you can say that you have a law. So it's just a observation that has been repeated. It is a repeatable observation. So science is like that, observing the universe and trying to figure out the laws. So one of such observation is that, as the story goes, Newton is a professor in Cambridge University sa Europe. But during that time, there was a bubonic plague. So it's like this coronavirus that we are experiencing right now. And there was a bubonic plague, or the death, what's the Black Death, no? That plague which killed around 1/3 of Europe, I think. Okay, to escape the plague, he went to a different place, and there, since he cannot teach, no, he was sitting near to an apple tree, and he observed a falling apple. And based from that observation of falling apple, give him an idea about other falling objects, like falling spoon, falling clothing, falling wallet, and using the observation that falling thing, so it's like observing a knight moving in L direction. He inferred that there must be an invisible pull. So we do not know what is it that is pulling. We do not know if it is the same as the atoms in René Descartes. Again, René Descartes has gravitation, but his gravitation is gravitation by contact. Everything is in contact. There is no such thing as space. It's like there is no such thing as empty space. It's like the the worldview of Rene Descartes is like the fishes, similar to the worldview you will create if you are a fish living in a water. There is no such thing as empty water. The water is composed of smaller atoms that are interacting together. But for Newton, to Newton, he observed a particular pattern. There is a thing, there is something that is invisible that is acting on different objects. The invisible pull. Okay. And during that time, Aristotle has, Newton has a secret weapon. He has an edge over Rene Descartes. By the way, they are centuries apart. For Newton, he has an advantage because during that time, there is something discovered called the Torricelli vacuum. Okay, what is the Torricelli vacuum? Okay, suppose you have a tube, a test tube, and then you fill it with mercury. According to Descartes' worldview, this tube has no empty space. It is filled with mercury. Mercury is a liquid metal. The one used in thermometer. It's a liquid metal. It is shiny, but it's liquid. Okay, and then suppose you place this one without leak. No, but there's a hole here. No, on top there's a hole there. You place it this way, such that it is facing the bottom of a basin. But this basin is also filled with mercury. There's also mercury in it. So the expectation is that since they are both mercury, there won't be any holes there. This test tube will remain filled with mercury. But what was the reality? What did they found out when they did this experiment? Or they found something else. They found that somehow the mercury is moving down. It actually moves downwards. Now, since it was filled with mercury, and now when it moved, it created, again, this is metal, it doesn't evaporate immediately like other fluid. This is a metal. So the metal created a space here. And according to Newton and the other scientists, the space here is a vacuum. It is an empty space. It is not like what Rene Descartes said, that there is no such thing as empty space. In other words, they have disproven that there can be no empty space. So, okay, so there is an empty space. What else did they observe? You can create the setup such that when the mercury moves, you can have a thinner test tube. When the mercury moves, it will create a bigger space here, a bigger vacuum. So now they shattered Rene Descartes' worldview, that everything is made up of matter. Even everything is filled with matter. Even the empty space that we are seeing, we are observing. Okay, so it was disproven. Newton also observed that gravitation is actually an acceleration. So here we have two scenarios. Here we have a rock. If you try to drop a rock to your palm, it won't hurt. It won't hurt because the speed is not that fast. But if you try to go up a building and drop a rock, so the rock will actually move this in this pattern. First, it will start out slow, mahina muna, and then it will gain speed, and then it will gain greater speed, and then when it hits your palm, bang, it's going to hurt. Okay, based on these observations, he also observed that this movement movement of falling rock is similar to movement of a cariton, a cart that uh, started motion from rest. So like the cart now, it start out slow and then faster and then going at its maximum speed. So to him, there is an invisible force that is causing rocks to fall. Okay, so he proved that vacuums exist using the Torricelli experiment. No, and using that knowledge, he concluded that the outer the outer space is also a vacuum. So it doesn't have matter on there. It doesn't have the vortex. It doesn't have the Cartesian vortex. No, it is also a vacuum. And the planets there move because of inertia. So what's inertia? So let's compare that to worldview. Okay, let's have an object. Now, let's compare what would the two say with regards to the motion of an object. Okay, let's start with Rene Descartes. Okay, according to Rene Descartes, there's no such thing as empty space. Space is actually composed of interlock matter like this. So, like this. And if that object is moving, the reason for that is because it was in contact with another object previously. Okay. So if it tries to move, it would feel resistance because of these tiny objects. Okay. According to him, this also happens in space. This also happens in if you are going to throw a rock in the outer space. Rene Descartes would say that the rock is going to slow down. It's going to slow down. Okay. What about Newton? What would happen? How would Newton explain if you ask him what would happen if you throw a rock in the outer space? Okay, according to Newton, if you throw an object in the outer space, it will continue on the same speed. So it won't be slowed down because, according to him, the outer space is a vacuum. There are no particles, there are no interlocked particles in it. There are no interlocked particles. It is literally empty, like that space created in the Torricelli vacuum. So there you have it. If you throw a rock in the outer space, Newton would say that it will go on forever, or maybe on the end of the universe. But by that time, by Newton's time, they already believed that the universe is infinite. There's no end. Right? So if you throw a rock in outer space, it will go in forever. But for Descartes, it will slow down. Okay, and this knowledge was used to launch satellites. We have satellites. How did the civilization? How did the U.S., how did China, how did Russia, how did India launch satellites? They actually use Newtonian physics. So they use the idea that an object in motion will remain in motion, no, unless it is stopped by something, by another force. Okay, so how did the civilization, how did the human civilization use that knowledge? No. So here, let's say the satellite is here. I'm going to use a box to illustrate later. To illustrate that this is a satellite. No. If you're going to launch the satellite this way, it will go, let's say, far from Earth. It will go on forever in that direction. If you're going to launch it near Earth, it will start to be attracted by Earth's gravity. It will curve like that. If you try it further down, you are going to launch it in such a way that it will uh, descend to Earth sooner. No, it will go on like that and then start to descend to Earth sooner. Okay, but there is a route, or there is a specific uh, orbit where if you launch the satellite, instead of going out, it will spiral a lot. No, it will spiral a lot here, and the deviation is so minute that you cannot tell if it's going to go out or out its orbit, or it's going to go in. It's going to drop on Earth. So like that, you calculate its movement such that it's going to follow this route with very, very, very minute deviation. And because we already know this law, the fact that the outer space is a vacuum, now you don't need to constantly add fuel to your satellite. It doesn't have to be kumbaga, with a booster rocket all the time. No, you can switch the booster off because an object will remain in motion forever. All you need to do is adjust its trajectory, no, such that the satellite is going to follow this route. No. Same thing if you're going to explain why the moon is in orbit with Earth. No. Why the moon is in orbit on Earth with Earth. So, he won't explain it using vortices. No. He won't explain that there is a particles that is moving around Earth. He will explain that the moon is actually in orbit because its trajectory, actually it's not perfect that the moon is stable there. No. It used to be near Earth, then it started to revolve outwards with very little deviation. So it was revolving around Earth with very, very tiny deviation. So Earth, the moon used to be near us, near the planet Earth, but it starts to revolve outwards. So it doesn't have a rocket engine, it doesn't have anything. So this situation, this scenario actually cements on Newton's worldview, that vacuums can exist, and then an object in motion remains in motion unless there's an object that will stop it or derail its direction. And that is the idea of inertia. Okay, so it's a very different worldview. There are empty spaces and things can go on forever. Okay, now let's move on to contemporary, the fourth worldview. So Newtonian. So if Descartes' worldview is clockwork, if Descartes' worldview is a universe made up of tiny interlocked particles, Newtonian worldview is that no, the universe is not made up only of tiny particles. No. You can have empty space. So if we go back to the substances that Descartes have, so you have here the mind, and then you have here matter. Okay. To Descartes, this matter filled up everything. No? It's like a glass being filled up. with everything. This one was changed. This view, this part was changed by Newton. To him, it is possible that there is a part of our universe that is filled with matter, and there is part of our universe that is simply a void, simply a space. Void. There's nothing there. Kumbaga, matter was removed in that area or location, and then our civilization take advantage of this knowledge. The reason why we have internet today is because the space is void. If the space is composed of if the space is filled up with matter like this one, then we have to refuel our satellites every time it loses trajectory, every time it loses momentum na resistance ng particles in the outer space. So yan. Okay, so that was Newtonian worldview. Okay, now let's go to contemporary worldview. So this is the worldview of scientists today. No, actually, it's a very different situation unlike the past. Okay, so today we have pursued theories. There are theories that are accepted in science, and there are theories that are pursued using mathematics. They are trying to examine the math of the theory and try to figure out what interactions or what objects could exist. So example of that, a very good example of a theory that is used today, or a contemporary theory. A very good example of a contemporary theory is the general relativity. The math of general relativity. There's an equation in general relativity. There's an equation that describes how space bends if there is a mass on it. So there's an equation. It's called the field equation. And what happened is that you can examine the equation and try to look at the extremes. What would these equations predict? And it turned out that it is possible to stretch space-time this way, to create a incredibly narrow bend. Like that. It can go on downward, so on. There's no defined limit. You can have a situation like this where near that hole, the gravitation is incredibly strong. And this was predicted using a mathematical equation. Then later on, they discovered that these holes actually exist. There were properties that these holes should exhibit, and so on and so forth. And they discovered the properties. And they actually have a observation that the center of our galaxy, the Milky Way, is a giant black hole. I think it was called Gargantula. Gargantua. No, somewhere here at the center, you are here. So you have the Milky Way, the Milky Way, and we are here. Our star is here. So at the center, there is a black hole. Now you can look it out. But this one was not predicted. These black holes cannot be predicted using Newton's equation. You have to use a more advanced description of our universe, or like the field equation. So how does a field equation look? So this one. So it's an equation that has prediction. Okay, we have other pursued theories. The implications of general relativity, or the implications of that equation, were pursued by scientists. But today we have a lot of pursued theories, including M theory and string theory. No, they were proposing that there were membranes before our universe existed. No? There were kumbaga, eternal membranes, but they're moving. No? And during collision, they could collide, and then it could create a Big Bang. No? Which is, oh my God, the theory is so mind-boggling. No? Not only if that happens, there could only not be one Big Bang. No? There could be a lot of Big Bang that's going on. So it's not an accepted theory. In fact, I told you that I've shown to you that this is a pseudoscience, not actually a scientific theory, because you cannot disprove a multiverse, because we are living on a universe. How would we disprove this one? Higher dimensional membranes. No, we cannot do it. So, but anyway, they are still pursued. Maybe we can find out a prediction or hypothesis that has a prediction. Okay, for now we have two worldviews. The science today is divided into two camps. No? During Aristotelian time, there is only the dominant Aristotelian worldview. During Descartes' time, there is only Descartes' clockwork worldview. During Newtonian time, there is an empty space worldview. Different time, different applications. No? Now we have two worldviews. On the fourth iteration of science, there are two separate worldviews, two different, and both are contradictory, but both are accepted. They contradict each other, but they are accepted. And what are these two worldviews? Now we have general relativity on one side. It's basically the science of large objects, like bending of space, large matter. So, no, including the non-empty space, that is included on general relativity. So it predicted black holes. So this theory was accepted, no, that space can bend. And the other contradicting application, we have GPS clocks, no, for general relativity. Newtonian for orbit, and then adjusting the clocks using the math from general relativity. And then we have quantum mechanics. No, this is the physics for small objects.